So I'll start recording the class. So pay maximum attention. So here we want to study the Kirchhoff's law. We have two Kirchhoff's law. The first one is called the junction rule. The junction rule. The first law is called what? It's called the junction rule. Now, what is the junction rule talking about? Now, pay attention. Let's assume that, see what we call a junction here, see. Or we can see a node. Look at it. Look at this junction. You can see, let's assume that a current I1 is entering this junction. Current I2 is leaving this junction. Current I3 is also leaving. So how do we now use Kirchhoff's junction rule to explain this? It's telling us that what? At any junction, the rule states that at any junction, the sum of currents must be equal to 0. That is, at this junction, the sum of the current at this junction, the sum of the current will be equal to 0. Now, we have some conventions we make use of. For example, if a current is entering a junction, we say that current is positive. But if a current is leaving, we say that current is negative, just like what we have here. Are we together?
Yes, sir.
Good. So from this junction now, if I want to apply Kirchhoff's rule, what do I say? I1 is entering the junction, so it will be positive. I2 is leaving, I3 is also leaving. It will be what? Negative. So according to Kirchhoff's, the sum of current at this junction will be equal to what? 0. So from here, I can just say I1 equal I2 plus I3. If you observe, I can say, okay, the sum of current entering the junction equal to the sum of current leaving the junction. Do you see that?
Yeah.
Exactly. Good. Now, is my background noisy?
No.
Are you listening to any cartoon like anything?
Cartoon like no, nothing like that.
Okay, good. All right, let's go. This is the first rule. Now, the second rule is the loop rule. Is the what? Is the loop rule. Yes. So see, this loop rule is telling us that, see, if I have a loop, a closed loop, for example, let me say, this is what we call like a loop. There you have some, you understand? Let me say you have some circuit elements, are you there, and so on like that. Something like this. This is what we call a closed loop, exactly. Now, if I have a closed loop, what's Kirchhoff's second rule is that what? The sum of all the potential difference must be equal to 0 around a closed loop. The sum of the potential differences must be equal to what? 0. Now, there are some convention you need to know in Kirchhoff's law. Just pay attention. You see, if you are dealing with this loop rule, junction rule is very direct. But if you are dealing with loop rule, please take note of something. Let's assume that you have something like this. Let me say you have something like this. Look at this battery, this cell across A. Take note that this short line is the negative terminal. This long line is the positive terminal. Now pay attention. You see, if I travel around this loop this way, will I have a positive voltage or a negative voltage? Now pay attention. If you observe the way I'm traveling in this loop, I'm traveling from negative to positive. Yes or yes?
Yes.
That will be a positive voltage. Take note of that. That should be a positive voltage. Are we together?
Yes.
Good. Let me say I have something like this. The cell is directed this way from A to B. And I'm traveling. Remember, this long line is positive terminal, this negative terminal. If I travel around the loop this way, will this be a positive voltage or a negative voltage? Now check. I'm traveling from positive to negative. So is that increase or decrease?
A decrease.
Decrease. So that will be a negative voltage. Take note of that. Now for resistor. Now take note of resistor this way. Now check. Because whenever we are applying that Kirchhoff's rule, we will surely travel around a cell or we travel around what resistor. So how do we do it? So pay attention So look at this. This is what AB. Now let's assume that current is moving in this resistor in this direction like this. Let's say this is the direction of the current. Now pay attention that current always move from higher potential to lower potential. What did I say?
Current moves from higher potential to lower potential.
Exactly. That is across a resistor. Okay.
Yeah.
Yes, exactly. So across a resistor, current travel from what? Higher potential to lower potential. Which means that whenever you travel around a resistor, definitely you have a negative voltage. That's negative IR. All together, remember Ohm's law. Okay.
Yes. Yeah.
Exactly. Exactly. So don't forget. So if I have resistor this way, sorry, whereby the voltage, whereby the current is traveling in this direction. Don't forget, for us to say the current is traveling in this direction, what are we saying? Remember, across the resistor, the current move from higher potential to lower potential. It means that if I travel like this around the resistor, now check, I'm traveling now in opposite direction with the current. Now, looking at this, the way the current is traveling, make me know that this is positive, this is negative. Because across the resistor, current travel from higher to lower potential. So look at this direction now. Will this be positive voltage or negative voltage?
Positive voltage.
Yes, because if you see negative, exactly positive voltage. Good. Now let me reverse direction. Let me say I'm moving this way. Now is this positive or negative?
Negative.
Negative voltage. Exactly. That's how we do it. Good. Now since
But
you've
sir,
known it, yes, I can hear you.
how will you know that? I don't know. Like the ends. How will you know which is positive on a resistor and which is
Yes, I'm
negative?
giving you. You see, a battery is clear. The
Yeah.
shorter length, but for a resistor, I'm giving you a clue that for a resistor, your current moves from higher to lower potential. Taking of this point, from higher to what?
Lower
To lower
potential.
potential. Are we together?
Yes.
So it depends on the direction of your current. If I say I have a resistor this way, for example, AB, and I'm assigning current to move in this direction, in your mind, just take note of this point, that the current move from higher to lower potential across a resistor. So which means that you have higher to lower potential. So whenever you now travel in this direction like this, you take this loop, you take note that well, here will be a what? A negative voltage. That's a negative IR. Are we together?
Yeah.
Exactly, depending on the direction. So this is the explanation to the rule. Now let's see how to apply the rule from simple to complex questions. Okay, let's look at some examples. Now, the first one, example one, they have something like this. Now, pay attention. So, yeah, you have R2 to be 10 ohms. I'm starting from simple to complex question. You have R1 here to be 8 ohms. This positive, negative. I will not write this for you in the next question. This negative, positive. 16 volts. So see what we have. So A, B, C, D. If you observe, this is a closed loop. This is a closed circuit. Aha. Now, if you check, do we have any junction here? Is there any junction here?
Junction.
Yes. If you want to say junction, you see something that is entering and leaving, something like this.
Okay.
At least
No.
you see, no, exactly. So that it's that way, it's the same current that is moving through all of them. You see, I can
Okay.
solve this thing by number resistors in series and parallel. But everything I want to do here is Kirchhoff's rule. Are we together?
Yes.
Good. Now pay attention. The first thing you should do here, whenever they give you Kirchhoff's rule, is that way. See, determine the direction of the current. how will the current move? Will the current be moving this way? You know that this way is the same thing that means saying moving this way. You know, the same that means saying moving this way. Are you there?
Yeah.
Or the current will be moving in opposite direction. How do you detect? Now, pay attention. Some people will choose any direction of current. In your final answer, if your current give you negative sign, it means that you have just picked a wrong direction. Are we together?
Yes.
Now, how do we even know the correct direction? Now, take note of something. How do we know the correct direction? Now, pay attention. Look at this cell that you have here. This cell is 16 volts. It will want to send current in this direction. In this direction. Look at this 12 volts. It will want to send current in this direction. From positive terminal in this direction. Now, looking at these two cells, which one has power over each other? Which one has the highest voltage?
The first one.
16. It means that what this direction of current will dominate. This direction of current will dominate. So this direction is current. That is correct. See, if I choose a wrong direction, I will have what? Sorry, I'm coming. Yes, I will have a negative answer. Altogether. Okay,
Yes,
let me now say I'm giving you something like this. Let me now say I'm giving you something like, let me say I'm giving you something like this. This is 6 volts. Now, how do we solve something like this? What do you think the direction of the current will be? Will it be this way? Remember that this one want to send current this way, and this cell want to send current this way. So which one will override each other? 12 volts, right?
Yes.
Exactly. That's just it.
Okay.
That's just it. So it means that my direction of current will be what? This way. You see that?
Yes.
Exactly. So let me say this I. Good. I've assigned current already. Don't come here and say this I1, this I2. No, it's the same current that is going. Are you together?
Yes.
Yeah, there's no junction here. Good. Now, what direction do we now pick? What direction do we now pick? Now, we'll endeavor to pick the direction of this 12 volt. That is the direction it is sending current to. So this is our loop. This is how we are going to take the direction. Are we together?
Yes.
Exactly. Because of this 12 volt is bigger. Nice. So that's best. So just choose that convention and your question will always be correct most time. Now let's go. By Kirchhoff's loop rule, the sum of the voltages will be equal to 0. Are you together?
Yeah.
Now, here I'm having 12 volts. Now, pay attention. Look at this one. Don't forget. Look at the way the current is traveling. Look at the way the current is traveling. And remember, current travel from higher to low potential. Are we together?
Yes.
So there will be a negative voltage, a voltage drop around this resistor. This resistor will consume voltage, and that's IR1. Are we together?
So wait to.
The voltage is current times time. Pay attention. Remember, this is positive voltage. Look at the way we are moving. Lower to higher, this is positive. Now, look at this loop. Look at the way we are moving here. Don't forget, how do we move around? Resistor is, see, higher to lower potential. So how do we move here? Will it be positive or negative?
Negative.
Yes, you can. Do you understand?
Yes, I get it now.
So that's IR1. So across this one, tell me, will it be positive 6 or negative 6?
Wait to have to negative.
Look at it.
It will be positive. No, negative.
Check. Negative. Why? Because we are traveling from positive to negative. Right? Exactly.
Yes.
So negative 6. So look at this one also. This also minus 10 I. Have you now?
Yes.
Yes. Let me just, this. Let me just do something like this. This 12. This one is a voltage drop. That's IR1. So my R1 is 8. Let me just help you write IR1. So I'll take it slow. Minus 6 minus IR2 then equal to 0. Do you see that?
Yes.
Exactly. So this is how we do it. So let's go. This is 12 minus, this is 8I minus 6 minus, this is what, 10I equal to 0. So what do we have? 12 minus 6 is what, 6.
6 minus 8
I. So therefore my I will be equal to 6. So what would that give me?
1/3.
What is it?
1/3. That's zero
Give me more,
three
please. 0.
zero
What?
point 33.
33 ampere. If I
Yeah,
have chose the wrong direction, you will see that I will
to be
have
negative. Yeah.
exactly
Okay.
nice. So that's for that. Now
Sorry,
I
what
have
the
a
question now
question.
say we should do?
What is it?
What the question say we should do? What the question say?
We should find the current in the circuit.
Okay, that's correct.
So let me even tell you, how do we even know that you are correct? Do you know how to know if you are correct?
Nope.
Okay, let's verify our answer. Let's verify our answer. Now let's see. See, if I ask you what is the total voltage entering this particular circuit, that is, look at this part, BC. What is the voltage drop around this? Remember, I have 12 volts minus 6 volts. That give me what, 6 volts, right?
Yes.
Good. And um my resistor here is how many?
It's 8 ohms.
8 ohms. Are we good?
Yeah.
Now I want to do something. Remember that V equal to IR. Are we together?
Yeah.
So my voltage is 6. You will see, I want to do something. I can decide to, okay, I'm coming. Let me even see how to, okay, let me verify it. Let's see if we will get this 8 ohms back. My current is 0.33 times R. Now, say 6 divided by 0.33. What do you have?
Okay. 6 divided by 0.33. That's 18.
What is it?
Got 18.
Wait, I'm coming. I'm coming. Wait. Wait, let me take that again. I'm coming. So 18. Wait, let me see. Okay, yeah. Pay attention. That's 18, Abby. Yes, yeah, correct. Don't worry. That's 18, Abby now.
Yes.
But you know what that 18 is standing for?
The
You know what that 18
total. No, I don't.
exactly this and this all together?
Yes.
Exactly, because that's the voltage drop across these two resistors. Exactly. So if I
Okay.
do as if I don't know this resistor, I look for my I. I look for my what R. You see that what you are going to have the thought. So it means that what your answer is. It makes sense. Okay.
Yes. It's my
That's
understand.
this one is very simple. This is just very simple. So let's move to something. I'm making it complex, small like that. Okay.
Yeah.
Next question. So I've given you the one of very single and simple. Okay, I'll not put the signs for you again. All right. This is another question. Now, first thing, remember I've given you some steps. Let's
Yes.
assign the current first. Let's assign the current first. That's the first thing. Let's assign the current first. Now, how do we assign the current? Just pay attention. Remember, this, let me help you. If you look at this guy, it will want to send current in this direction, right?
Yeah.
Okay, good. Let us pick this junction. Let's pick this junction. Now check. Look at this junction here. Pay attention. Remember, we don't know whether this current can go in and leave. We don't know that some can go in and leave. We don't know that some can go in and leave. We didn't just leave. Okay, let's do something. Remember that this guy, we want to send current in which direction? Here, right?
Yes.
Exactly. So let me see. There's a current entering here. I'll still label I1, I2. So I have a current entering here. Now let's look at how this one want to send current. Remember, look at this one. Well, check. See, this guy want to send current in this direction, right?
Yes.
If you observe, this guy also, this man, how does he want to send current? Also this direction, right?
Yes.
Remember, from the positive, exactly. So it means that surely current is entering through this part. Are we together?
Yes, sir.
If you go and try this problem, choosing wrong direction, you see that you get the same answer, but your sign will just be different. I have another current here. So the next one, can you tell me how will current try to enter here? Are you trying to say, will it come this way or will it leave this way? What do you think? What do you think? Just look at this 14. Remember, it's taking the current here. Nothing is even opposing it. So let's assume I have my current here, I. So let me say this is I1, this is I2, and this is I3. Are we together?
Yes.
Good. Now, so look at the way I'm going to solve the problem. At junction C, what they have, the sum of the currents is equals to 0 according to Kirchhoff's law. So it means that I have the sum of the current entering is equal to the current leaving. Can you tell me which of the currents can you see that is entering this junction? Which one is
I1.
entering? And what? And I3. Have you seen it?
Yes, yes, okay.
Then equal to what? I2.
Okay.
That's Kirchhoff's rule. Or you say minus I2 equal to 0. So see what I have. So let me keep this on somewhere. Or I can just say, okay, wait, let me just keep this on somewhere. Let me keep the equation somewhere. Nice. So I've gotten the current already. Next is that let us look at the loops. We have two loops here, 1 and 2. So let's examine the loops. Now check. If you observe this guy, we are picking this loop this way. I believe you know why we are picking this loop this way. Look at the way they are sending currents. All together?
Yes.
Exactly. Okay, so let's go. Looking at this loop, look at this second one again. How do we think we have to? If you look at this 10 volts, in this second loop, it want to make the current travel in this direction. All together?
Yes.
Exactly, just like this. Travel in this direction. Like, so we are choosing our loop this way. So this loop 1, this loop 2. So at loop 1, now don't forget Kirchhoff's rule. Looking at this plus 14 volts. Now, if you look at this, remember the way current is moving here. You see this I2 that you are seeing, this you see this I2 that you are seeing here is the same thing that is 0, okay?
Yes.
Exactly. So if you look at the way this thing is traveling, it will travel across this resistor this way. And don't forget, since the current is moving in this direction, the voltage across a resistor will be a voltage drop. Yes or yes?
Yes, yeah.
So this will give me minus 4I2.
Yeah.
Good. Now, across this 10 volts, will have a positive or negative 10? Check. The current is moving from low potential to high potential. That will be what? Positive.
Positive.
Okay, that?
Yes.
Just 10. and check across the resistor. Since we are moving along this current, don't forget, the current will travel across this resistor from higher potential to lower potential, right?
Yes.
So that will be a what? Voltage drop.
Voltage
Voltage what? Drop.
drop.
Exactly. That's 6I2. What again? That's what? Equal to what? 0. So if I solve from here, what do I have? 24 equal to 10I2. Have you seen that?
Yes.
So what's that my final answer here?
Okay. That's 2.4 amps. That's 2.4.
2.4, thank you. I'm coming. I'm coming 14 plus. Wait, I'm coming. I want to check something. This 24 and this 10I2. Okay, please. I want to just check something. I want to check whether I have some. This 14, 4, 6, 10. This is 2. 10 minus 6. Okay, sorry. Look at this current here. Check this current. Please correct me. Look at this current here. Observe that there's a particular error here. Let me explain that again. Let me explain this loop again, please. Now, check here. This is 14, right? I'm moving from low to high. That's 14, right? Look at this resistor here. The current is I2. Across the resistor, that's the voltage drop. So I have 4I2. If the current travel around this side, now check. Look at this loop. This is a positive 10, right?
Yes.
And across, remember the current across this resistor is 1 ampere, right? So it's I1 ampere. So across this resistor, we are moving along the direction of this current. Don't forget, the current across the resistor is from what? High to low potential. So if we are moving from high to low potential across the 6 ohm resistor, that will be a voltage drop. That is a drop in voltage. And what the voltage across this resistor, that's 6I1. Exactly, then equal to 0. All together? So solving simultaneously, what do we have? You observe that I have, if I bring, see, 4 plus this will give me 24 equal to 4, let me say 6I1 plus 4I2. If you observe, this one and this one, we go to the other side. So I'll call this my equation 1. Are we together?
Yes.
That's for that. So at loop 2, now let's see how we are traveling at loop 2. Now check. This is, we are moving across this 10 volts from low to high potential. So that's plus 10 volts. Now look at this resistor. Now check very well. We are moving from, you can see the way the current is trapped. You see, a way to make this thing easy for you is that you can just come and label the charges on your resistor. You can see how I got positive and negative. How do I get it? Remember that I told you that if you have a resistor, don't forget it from the example. If you have a resistor and I said a current is moving this way, so you assume this is high potential and this low potential, okay?
Yeah.
Exactly. That's just what you need to know. So since the current is traveling this way, and I'm also moving in that direction, that's high to low potential, that is what? Negative 6I1.
Okay.
Then look at this one. What do I do here? Look at the current across this one. Check. I3. Look at the way the I3 is moving. So what do we say here? Check. See, we are moving this direction. And you look at it too. Look at this current. Current is moving from high to low potential. And look at the way we are moving. So what do we say? Do you have a voltage rise or voltage drop?
Voltage rise.
Exactly. Because if you observe, we are moving from low to high potential. That's plus 2I3 equal to what? 0. And from here, don't forget, what's our I3? Our I3 from here is equals to I2 minus I1. I2 minus I1. So I'll be replacing with that. Okay. 10 minus 6I1 plus 2I3 is what? I2 minus I1 equal to 0. So what do I have there? I have 10 minus 6I1 plus 2I2 minus 2I1 equal to 0. So check. I'm having 10 here. This and this will give me what? Minus
Minus
8I1
8I1.
plus 2I2 equal to 0. So if I take this 2 to the other side, what do I have? 10 equal to 8I1 minus 2I2. This is my equation what? 2. All together?
Yes.
So let's solve equation 1 and 2 simultaneously. So what you just solve simultaneous equation and you are good to go. So how do we solve simultaneous equation? Let me multiply this equation by 2. I'll be having 20 equal 16I1 minus 4I2. So look at it now. We now have 4I2 here plus 4I2 here minus 4I2 here. So what do I do? I'll add both equations together. So what do I have? This plus this will give me 44. 6I1 plus 16I1. That will give me 22I1, right?
Yeah.
And this will cancel out. So therefore, my I1 is equals to what?
2.
2 ampere. If you observe, it means that this direction we predicted was correct. You can see the trick for predicting the right direction. All together.
Yes.
If you try this thing and reverse the direction, you observe that you're having negative. Good. So I've gotten my I1. How do I get my I2? You can just put it in this equation. Okay. I can say, okay, 10 equal 8I1. And my I1 is 2 ampere. So I can just say 2 minus 2I2. So my 2I2 equals 16 minus 10. Hope you get you I'm solving this thing. It's small
Yes,
math.
I guess it's
So 2I2 equal to 6. Therefore, my I2 is equals to what?
3.
3 ampere. Exactly. So how do I get my I3? Don't forget that I3
I2
is
plus
equals to what?
I1.
I2 minus I1. So what's my I2? 3.
Mhm.
What's my I1? 2. And that's what? 1 ampere. Right? That's correct.
Yeah.
That's it. We chose the right direction. That's it. Do you
That's true.
understand?
Yes, sir.
Basically, assign the current to the resistor. Look at the batteries. They will tell you where they want to send current. So if two batteries are counteracting each other in direction, choose reference to the highest battery. All together.
Yes.
Exactly. So now pay attention. Let us verify our answer. I want us to be doing this. Very important. Let us just see. Let us just see. So my I1 here is what? What's my I1?
I1 is
2
2,
ampere. What's my I2?
3.
3 ampere. What's my I1?
I3 is
1
1.
ampere. All right, play I'm coming. Okay. Do you know that this thing is correct?
Looks
Hello.
correct. Yes, sir.
Okay. Is right. So if we check current entering equal current leaving, 2 plus 1 is entering and 3 is leaving. So that is correct. Yes, 2 plus 1 is leaving. So that's correct. If I want to verify this, it could lead to some other calculation, but you will see that you are right. Yes. All right. That's for this. Let me see some other challenging problem. Hope you get the concept now.
Yes.
Just as simple as this. No hard at all. You can have it as complex, more complex than this, but you still get the same answer. I'm coming. Please hold on. If you look at this resistor here, check this resistor. You can verify your answer this way. Let me tell you. Um, I'm coming now. Check. If you look at this resistor, look at this resistor here. If you observe the voltage entering this resistor is how many? Check. I have 14, the same direction with 10. That's 24 volts. Abi now?
Yeah.
Good. Um, I'm coming. What am I saying here? 24 volts. Okay. I'm coming. I want to do something. This is this plus this 24. 24 volts.
How are those two in the same direction? In the same direction?
They are. If you observe, they are going really see negative to positive, negative to positive. It's the same. If you observe very well, there's something I'm trying to do. 24. Okay. Do you know that? Do this for me. 1 over do this one for me. There's something I'll tell you. 1 over 4 plus 1 over 6. What do you have? And divide your answer. Just do this for me. What do you have?
That's 0.417.
1 divided by your answer.
Okay. That's 2.3, 2.4.
Okay. I'm coming. Okay. No, let's. I'm coming. I will show you. Are you done writing this?
Not yet. I'll write it when you send the note.
When I send it, okay. Oh, sorry, I was actually waiting for you to. Okay, no, wala. Now, I will give you the ones that you are going to solve. Just light ones, not something too complex. So, use your own exercise.
Okay.
Have you written it?
So is that 3.5
Yeah.
or 35 ohms? This the value of the first resistor
Which one?
on the
Yeah.
exercise. Yes. No, this one.
This one.
No, the
12.
first one.
I'm coming. This 12 ohms. This one,
Yes.
3 ohms.
Okay. So is this all?
Yeah.
So
That's
I just
everything.
find the current in
Should I
this.
give you? Yes. You can just find everything. Find the current in the circuits. Yeah. Don't look
Okay.
at it. Just find the current in the circuit. Should I give you another one?
No.
Okay. Just study this very well. These are just normal things that you will see.
Okay. So can you just solve it? I'm not getting it.
Okay. I can solve it for you.
Yeah, I'm not getting it.
Yeah, I'm coming. Wait, let me see. And I gave you simplest one actually.
I'm still trying to understand the loop and stuff.
Okay, oh yeah, look at it. This is what you will do. I think this is what I'll be making it simple for you to. I'll be doing something for you. See, firstly, look at this positive, negative. This guy we want to send current in this direction, right?
Yes.
So it means that surely I will know current is entering this part like this. All together,
Yeah.
to send it current in this direction. So this label I1, I2, I3. So I can say by Kirchhoff's rule, I1 equal to what? I2 plus I3.
So why is that I2 going down?
The I2 is going to this resistance.
Down.
Yes.
Okay.
Now, next is that we will now draw our loop. So, looking at this loop, what do we do? The sum of the voltage equal to 0 for loop 1. The sum of voltage equal to 0. That's for loop 1. Now, check. This 24. Remember, the current is moving this way, so label this positive, negative. Current is going this way, label this positive, negative. Current is going this way, label this more positive, negative. That will make it simpler for you. So just take note that you are traveling from plus to minus, negative voltage. From minus to plus, positive voltage. So let's go. What do we have there? 24 minus 3I1. What again? Minus 4I2 equal to 0. So the 3I1, that's 24 equal to 3I1 plus 4I2. That's my equation 1. All together?
Yes.
Now look at this second loop again. Okay? Look at the second loop. I'll take my loop like this. L2. Look at my current. So take a look this way. All together? Now,
Yes.
something else. Well, yes. Just take a look this way. That's nice. So what do we have? So if you mistakenly take the wrong direction, it will affect your sign. Let's go.
So why do you have a second loop when there is no voltage on the side?
It does not mean anything.
Oh.
Yes. Let's go. What do you have there? Now check. We are moving this way. That's minus 12I3. Yeah, negative to positive. Plus 4I2 equal to 0. All together?
Yes, sir.
And don't forget, what is my I3? I3 equal to I1 minus I2 from here. So I have minus 12, I1 minus I2 plus 4I3 plus 4I2 equal to 0 minus 12I1 plus 12I2 minus 4I2 equal to 0. So from here, I'm having that minus 12I1 plus 8I2 equal to 0. So looking at this, you will see now. I can make anyone my subject. So check 8I2 equal to 12I1. So I can say, okay, divide both sides by 8 to find my I2. So my I2 equal to 4 in this one give me 3, 4 here give me 2, 3 over 2 I1. So I can now go ahead to put my 3 over 2 I1 for my I2 here. So I have 24 equal 3 I1 plus 4 3 over 2 I1. Because my I2 is 3 over 2 I1. So 2 here 1, 2 here 2. 24 equal 3 I1 plus 6 I2. So plus 6 I1. 9 I1 equal 24. So my I1 equal to 24 divided by 9 ampere. So since you have gotten this, my I2 will be equal to 3 over 2 times 24 divided by 9. 2 here 1, 2 here 12, 3 here 1, 3 here 3. So this is 12 over 3 ampere. It's as simple as that.
Okay.
Yes, you will get it with practice. Now, assignment. This will be our assignment. So this will be your assignment. That's psi. Is it hard?
Yes, sir.
And it's very simple, but you have to practice. If you try Kirchhoff's law first time, it is doesn't. I remember in my 100 level, so I think that I have to understand it because people are depending on me to teach them too. But I got it with time. If you just understand the concept, you get it. So that's it. So find everything. Mostly they will tell you to find the current in the circuit.
Okay.
Yeah, the currents mentioned the circuit. Yeah, that's all.
Okay. So I'll present the video today so I can watch it.
No problem.
Okay.
So that will be for today. So our next work will be on magnetism.
Yes, I'm already reading waves, sir.
No,
Okay.
okay now.
Okay.